Hi math friends, today we're looking at our study guide for triangles and angles including PLCBT, that's parallel lines cut by a transversal. If you're really cool, you will remember PLCBT. So let's check out what skills we have learned so far. Uh, the angles of a triangle. Remember we have to remember that the angle sum of a triangle is 180. So for this one, it says determine the measure of the third angle. Well, that's this one B. We don't know that. So we can add the two angles that we have, and remember that we have to show work for this. So we're going to add those together, and that's going to be 96. And then we're going to take that away from 180, because that'll be the remainder, and that'll be what's left over. So if I subtract 96 from that, we get 84. So we could write B is 84 degrees. The second part we might have forgotten. We didn't use this much in class right now, but the lengths of the sides from shortest to longest. What we need to remember is that the shortest side, so shortest side is 28. The side across from it corresponds to it. Not next to it, not next to it. We don't want next to it, we want across. So straight across, Z. So that's going to be the shortest side also, Z. And then the next one, in order 68's the next in our degrees, increasing order. So then Y. And then the longest would be the one that we just found. So this 84 degrees, the one across from that is X. It can be kind of tricky to remember to go across, but remember to go straight across and not next to. Alright, same idea for the second one here. So good practice here. We're going to go ahead and add 68 and 97, the two angles that we know. And it's going to be 165. And then we're going to take that away from 180. And that means that our third angle will be 15 degrees. Alright, so then we're going to say X is 15 degrees. And this is a great way to show work too. Listing sides from the shortest to longest then. Our shortest is going to be that 15, and across from there is going to be M, so side M is the shortest. And then let's look at our next shortest, 68. Across from it is going to be O. And then the very last one is 97, across from that is N. Alright, so it should be like that. If you're ever confused as to which one's going to be across, I'll show you a neat little trick here that turns into a treat because it always works. If I look at my 97 degrees, the sides next to it are the ones that the angle is touching. So M and O are touching it. The one across from it is going to be N. Right? And you can do the same thing with the other angles too. So like the 68 degrees, if I look at 68 degrees like this, the sides that it's touching are right here, M and N, so the one across from it is O. Alright, let's move on to these then. These are the outside angles, the exterior angles, and what we learned from this is that the measure of the two angles that are not next to it, so not this one right here that I'm going to draw a line on, are equal to that angle on the outside. Alright. A little bit of algebra here. We have to add those together. So 4x and x is 5x equals 115. And then remember to solve this, we have to divide by 5. And if we do that here, we do that on the other side. So we get x is 23. Remember to read the question again. So the question here, or the statement is determine the measure of angle A. So angle A is only x. So we could say angle A is 23 degrees. Usually we write measure of angle A like this, and make sure that we show all this work for it too. Now if we had to find B, we would do 4 times 23, but they didn't ask us for B here. Number 4, measure of angle L and M. So this isn't labeled really well. I'm assuming L is going to be this angle right here. And what do we know about a line? Remember, a line is 180 degrees. So let's show our work for that. So 180 minus the one next to it, 90. That's going to equal 90. So that angle right there is also 90 degrees. So we can say measure of angle L is 90 degrees. And it really helps on these to circle them because we're finding a couple different things. So if I circle my final answers here, we're going to be better. We're going to be going a little bit better here. All right. This angle here. So now this can be kind of tricky. We need to look at this in a couple different ways. This triangle right here and this outside angle, this 142. So this is kind of like number 3. Your two inside angles, x plus 90, that are not right next to it, are going to equal that 142. If you have to kind of spin it around to see it, that's fine. Just to make it look like number 3 was, you can definitely do that. All right, so a little bit of algebra here. Do the opposite that we see. Opposite of that is minus 90. And we should get 52 here. So then at the end we're going to say measure of angle M is 52 degrees. Because it was only x, it wasn't x plus anything or x times something. So there's our two answers. We circled them and we showed work. We're good. All right. Let's check these other ones. So here we have parallel lines cut by a transversal. So when you see these, this is your PLCBT. All right. And what tells us that? It's this part right here. M is parallel to N. So I know that these are parallel. It might help to go ahead and mark them like that, just so we know how it starts. And they tell us that angle 2 is 136. So I'm going to mark this as 136. So that's given to us. We have to define the measure of the other 7 angles. All right. So we want to find that and we want to show our work for it. So we know that across from it is vertical angles. So this is 136. And it says to show our work. So if I'm showing my work here, I could write vertical angles. And that would be a good way to show that. And we can write the word vertical angle here. All right. And then we also know that a line, so if I can just imagine this line here, for angles 1 and 2 together is 180, right? So if I do 180 minus 136, we'll get the remainder. So 180 minus 136, we get 44 degrees. And that's showing our work too there. All right. We also know this holds true for number 3. So this is going to be the same as 44 degrees. And it might help to write vertical angle because it's across from angle 3. All right. And I'm going to draw a quick drawing here. Remember vertical angles, anytime you have lines like this, whatever angle this is, let's say that this is 55 degrees, the angle across from it is going to be the same. So just a quick reminder of how vertical angles work there. Let me erase that too. All right, the other 4, if we remember how corresponding angles work, we can mark these right away. So these are going to be the same as the other 4 because remember it's like if we copy it and slide it over to a translation, these will all end up being the same. All right, I'm kind of running out of room here to show my work. So a good way that I'm thinking about showing work here is to circle these, and we could write that term. We could say these are corresponding angles. And that would be a good way to show that you know how to get them. Once you have the 4 on the PLCBT, you can slide it right over, and they're the exact same in the same position. So top right is 136, bottom right is 44, bottom left is 136, and top left is 44. So these are going to be corresponding angles. All right, and that would suffice for showing your work for these two. All right, number 6, how do we show that these are similar? So we got to find at least 2 angles that are the same. So we know that this right here is 68 and this is 68 because they're marked. Awesome. So how do we say that now too? So we need to make sure to, we're going to say angle P is congruent to, now we don't want to say angle N because there's two ways that it could go. So for N, we need to go from O to N to M. Yeah, a little confusing, but we can label it with 3 as long as that one's in the middle, that N is in the middle. So this is congruent. And why is it congruent? Well, it's because they tell us, right? So we could say they are labeled as 68 degrees. All right, so that's our first pair of angles that are congruent. Now the other thing here too is sometimes we have trouble seeing this, but we're trying to prove that these triangles are similar. So we got PMQ, that's the big one here, is congruent to NMO, the small one. So they have something in common. If you're looking at it and you're saying M is in common, that's right. This angle right here, I'm going to label that with this kind of marking, is the same in both. So remember, this can look kind of strange, but we can say angle M is congruent to itself. Right? And then we can say they share this angle. Both of those triangles share that angle. They have that same angle there. All right? So then the end of our proof, I'm running out of room here a little bit, but we can say since the triangles have two pairs of congruent angles, they are similar. Because from there, those last two angles are going to be congruent, but we need to do the least amount of work possible by showing only two of the angles are congruent, because the third obviously will be. All right, number 7. So we got a big diagram here. We're trying to show the unknown angles for F, G, and E. And I think this was a little typo here, but we're trying to say that these lines are parallel. This GF is parallel to HD. So that's what we should have marked there. All right. So we know that this angle inside this E here is 69. So the other side right here, this is vertical actually. So this one we can label as 69 degrees. And it says show your work, or it's trying to say show your work, but it kind of lost its voice here. Maybe it just ran out of things to say. We're going to write here vertical angles. Because if we know that they're vertical angles, we don't need to do any work for it except tell the type of angle that we have. So vertical angles. Okay. All right, then we need to find a few more. So if I know that that's 69, that's the same as that. What we need to do is check out these lines here. And look, this is going to be really cool here. If I know that this is parallel, sometimes it helps to extend this, use a different color. I know that that's parallel to this, and that makes both of these lines transversals. So let's go ahead and look at this line first as a transversal. Now this looks similar. I'm going to flip back real quick. This looks really similar to this one if I just look at the green lines. So I know that this is 89, and I'm going to go ahead and mark this like this with 2 stripes. So I know that the corresponding angle would be over here. And I know that the vertical angle to that would be right here. Now we can go straight from here to this inside angle because they're also alternate interior angles. Or you could say, hey, corresponding and then vertical. Whichever way works best to show that you know it. But you have to write something down to show that you know that that's 89 degrees now. So I'm actually going to say the short way. I'm going to say straight to that inside there, they are alternate interior angles. This was all in the vocabulary that we did before too. Alternate interior angles. And it's also in the practice that the digital practice that you're doing too. Alternate interior angles. So that would be a good way to show work. If you're telling me the type of angle that you see, then great, you got it. All right, that leads us to our last one, this F here. So F, you can do a couple different ways. If you recognize a different transversal here, so I'm going to draw that in red, you can do that. Or we can use our triangle sum theory to help us out too. There are so many ways to do these that sometimes it might get confusing, but I'm going to look at this red line now. So look at that red line as your transversal, and if we do that, then we can see, hey, look at this. I got 22 here. I'm going to draw this just with one purple stripe. And that corresponding angle is going to be all the way up here. And then that's also going to match here. So again, this is alternate interior angles to the other 22. Another way we could do this, though, let me check out one more way. Like we said, there's another way to do it. If I know this is 89, we can do our triangle sum theory. We can do 180 minus the two other angles. So minus 89 minus 69. And we get 22. Pretty cool that it works out the same way because it should. So this is 22 degrees. And showing our work, we showed work up here. All right, so good luck studying, and you can do it. Good job, math friends.